Good evening everyone. In this particular video, we are going to discuss about the famous coin and card experiment analysis. So let us write down the heading: coin and card experiment analysis. So what is this particular experiment? We have done this experiment many times. So what is the experiment? Here we take the glass. This glass is kept on a horizontal table, right? And here we take one card. Now on this particular card we keep a coin. So this is coin, this is card, here is a glass. And what we do, we have done this experiment many times. You can try this at home. Okay, so we apply a force, we push this particular card like this, we push it like this. Okay, so when we push, we give it a push like this. Okay, so when we push this particular card with a finger like this particular coin, we find it experimentally, when we do this, we find it that it falls into this particular glass. So why this thing is happening, that we are going to analyze by using Newton's laws of motion. So what is happening? Let us analyze this particular system. We apply a force here. This coin, instead of moving outside this in this direction, it falls into the glass. If we analyze this system, we'll come to know that, okay, I will give you a very simple situation. Instead of giving it a jerk, instead of like pushing it very fast, you hold the card here. Okay, you hold the card here and you take it gently. What is going to happen? The coin will travel with the card. So who is taking card? Your hand. You are taking the card. Who is taking this coin in this direction? The coin is taken by force, which is frictional force, high frictional force, because they both are in contact with each other. So this F, small f I am writing, this is small f, is a frictional force, exerted by card on coin. This is the frictional force which is exerted by the card on the coin, right? So this frictional force, this is a force and the mass of the coin is remaining constant. So we can write down this force is equal to mass into acceleration. We also know this particular frictional force is equal to mu, which is coefficient of static friction here, into normal reaction. And here what is normal reaction, students? The normal reaction is weight of this particular coin. And what is weight of this particular coin? It is equal to m into g. So which is equal to m into a. So m will get cancelled. What is this m? Is a mass of card? No, it is a mass of coin. So m into m will get cancelled. A is equal to mu into g. This is the value of acceleration. So this mu value can be 0.3, 0.2, 0.5. Okay, depending on the nature of this particular card and the surface of the coin and the card. And g is acceleration due to gravity. Its value is 9.8. So this number will come something like it will be 0.3 into, let's say, 9.8. So you can do this calculation, right? Now, why this coin falls into this particular glass? Why this particular thing is happening? This acceleration is which is equal to mu into g, and this acceleration is constant. So we can use equations of motion for constant acceleration. So equation of motion for constant acceleration, when we write s is equal to ut plus half of at square. Initial velocity of this particular coin in this horizontal direction. What is that initial velocity? Initial velocity of this coin in the horizontal direction is 0. So 0 into time is 0. Plus, I will assume this particular direction as plus half into, what is a? It is mu into g into t square. So this is the value of s. Now you analyze this particular equation in very detail. See, half mu into g. We have already talked about this mu g, and this half factor is there. Now here t square is there. When you are pushing this particular card, you are giving it a very small time. So this time value is very small and you are doing the square of it here. So what is 0.1 square? It is 0.01, so it is even smaller. Are you getting my point? What is the distance? What is the approximate distance between this particular point, which is coin, and this end of the card? It is this much acceleration is there. This acceleration value is something that we have discussed. It can come like I have designed some numericals also, so you will be able to do some calculations. I have designed some association and reason questions also on this particular thing. So you will be able to apply your skills, like whether you have understood the topic or not. By solving such kind of questions, you will be able to know whether you have really understood this particular topic or not, or you have to do again the revision. It does not matter whether we understood or whether we are able to solve the problems or not. We have to do revision again and again and again. We have to update our notes, right? So S is equal to ut and u is 0. So plus half of at square. A value we have put it here, mu into g into t square. Time vector is very small, and because of which the displacement traveled, or here the magnitude of displacement, I will say in simple words like distance. Here the distance traveled in this particular direction is very small. And when this distance is small, this distance comes out to be equal to something like in millimeters it will come out. And the diameter of this particular glass, or the radius of this particular glass in some centimeters. So if the radius of this glass is, let's say, 2 centimeter, and the displacement of this particular coin in the forward direction, when we do all this thing, it will come out in some like millimeters or so, then definitely the coin is going to fall into the glass. How many minutes are there? Okay, so this coin is going to fall into the glass. Yes or no? So that's it. This is what it is. So many times what happens is, we see the explanation that the body is at rest, it wants to stay at rest, and the body in uniform motion, it wants to continue to be in a state of uniform motion unless and until an external unbalanced force acts on it. This is Newton's first law, and it is valid in the only inertial frame of reference. So all these things we have studied. But so I'll ask a question, that can we use first law in explaining this particular situation, that the initially coin is at rest, and still since the coin wants to stay at rest, and that's why when you do this particular thing, the coin wants to stay at rest, and that's why it falls just down. This explanation is incorrect explanation, is incomplete explanation, is not a correct explanation. Okay, what is the correct explanation? That there is an external force on this coin. What is the external force? The external force is a frictional force, and this frictional force is accelerating the coin. The value of that particular acceleration comes out to be equal to this. Because of this acceleration, there is a displacement of the coin in the direction of acceleration, and this displacement comes out to be equal to this. The time parameter is involved here. You are giving a very small amount of very fraction of a second that you are giving for this coin to accelerate, and that's why the acceleration, due to this acceleration, the displacement comes out to be equal to in some millimeters, and the diameter of this glass is huge. It's somewhere around 3 to 3.5 centimeter or 4 centimeter. The radius is around 2 centimeter, and that's why the coin moves like a very small distance, or the magnitude of displacement in the forward direction, and that's why it falls into the glass. This is the whole analysis of this particular experiment. You can go even further. You can say that, so already we say the third law, how the third law is playing role here, right? And then the second law, and we know that in the theory part we have discussed that the first law is a special case of a second law. So all these things that we have discussed, I want all of you to take proper notes of this particular thing. If you haven't understood anything, please feel free to ask the questions, or you can go, you can rewind this particular video and you can see it again. So after this particular video, around 5 questions I have given. Attempt these questions very carefully, solve it on your own. Do not find the answer, do not search the answer on the internet. You may get the answers on the internet, but that is not the point. You have to use your own brain in solving this particular these particular questions, new questions you have to attempt, and thereby you have to test your abilities to solve the problems. Okay, so here I will stop. I hope you all understand this particular thing. If there are any queries, you can ask. Thank you very much.